Hi there. Right, we've talked a bit before about retrieval and how it works. Let's discuss now about slightly more complex use cases and where they can trip up and how we can help. Okay, so just to reorientate everyone again, we have our language model that has some of its own knowledge. There is also some corporate knowledge that has been vectorized or put into an embeddings model and is held in a vector database that the language model accesses. So let's just remind ourselves, we ask the model a question, it might try and find the answer from its own knowledge, it might try and find the most relevant chunks from vectorized context, and then it creates an answer and presents the answer back. That is a simple retrieval use case. We've talked about that loads. But things start getting complicated when you try and do this at scale, when you move away from single prompts into asking it to carry out a workflow. So let's pick up on that. Okay, so let's talk about the kind of use case that I've got in mind and what goes wrong. So I'm now an enterprise. Instead of having a simple question like how many days annual leave do I get, I'm asking something much more complicated, like review these 5,000 contracts or past case files, or go through all these CVs, any number of big, complicated, knotty, high volume, bulk reading and writing tasks, the kind of things that language models should be so good at doing, but loads of people are struggling to get them to do. Why does that struggle happen? Well, all of that information gets put into this box somehow. The context might go into here and you might end up with 10,000 documents instead of 10. And then this vector database gets terribly cluttered, and trying to find the difference, the semantic difference between all these chunks gets very, very difficult. So the process of retrieval really becomes a lottery rather than anything particularly scientific. Or perhaps you're putting lots of that information direct into the language model, into what they call the context window, at which point the language model has to go from running, a few 100,000 probabilities to millions and millions of probabilities. And of course, even with a very, very low error rate, the more probabilities it runs, the more likely those errors are to creep in. And of course, you've got the unknown of its knowledge. What has someone somewhere deep in the recesses of the internet put into that knowledge that is lying there waiting to disrupt this whole use case? And so you can see, just by simple fact of volume, because we've got 10,000 contracts, we're starting to confuse the vectorization, we can confuse the models, and everything starts either drifting towards failure or towards banal generalization, neither of which are very good. And this problem set, these exact issues, are what people in your business are spending months and months and months and hundreds of thousands of pounds trying to sort out. They're trying to work out, how do I put more context in? How do I make this vector database more granular? How do I get the latest, greatest, most expensive frontier model so that somehow it will be able to make sense out of these thousands of lines of gibberish that I've put into it? And spoiler alert, guys, they're not going to get there. This isn't the solution. Let me show you what is. So what does the actual solution look like? Well, it certainly isn't putting all your information into one ever larger agent, ever bigger prompts, ever more context. That just drives risk and problems and exacerbates all the problems that language models are famous for. The solution is to break your use case down into what we call precision agents, or what you might just call a workflow. And that's what I've done here. All I've done is I've replicated the components that we understand, our context, our vector database, our language model, and their knowledge, and I've replicated it through a workflow. Why does that help? Well, I can be much more specific in the task that I want each of these agents to do. I can give them less information each time. I can vectorize it much more clearly, and I can decide whether or not I want them to use their knowledge. So in this simple workflow, I've gone classify, clarify, reduce, and respond. So what does that mean? So we talked earlier about this use case. Maybe it's about analyzing 10,000 contracts for some clause of some liability or something. Now, we tried putting it all into one agent, one simple big use case, and it just didn't work. So what we're going to do is we've broken it down. So the first thing we do is we're going to put, instead of putting all 10,000 documents in, we might just put in their titles, or we might just put in summaries, so much smaller amount in context. That means it can be vectorized much more clearly. We're going to deny this first model access to its own knowledge. So all we're really asking it to do is classify those 10,000 documents. So you go, great, I'm interested in the contracts that are related to properties leases, for example. Great, so we've classified it now. We take to the next workflow. We can do clarification, because we know now we're only dealing with the contracts relating to property. Again, much less context to be grappling with, much clearer vectorization. The model knows what it's doing. And this one, we might ask it to use its own knowledge, because we want to understand, for example, where each of these property related contracts diverge from established industry best practice. And that might be really well served by the standard knowledge that comes out of these models. And then we're going into a reduction phase. So we say, well, actually, okay, we know we're just dealing with property things. We know we've clarified the ones. So now what we want to do is just take the ones that diverge from that industry best practice, the ones that are not normal. And we really want to get deep into them, really understand what that divergence is, what a potential recommendation would be to improve them. And that's where this final agent comes in with a really clear and clean task that's responding to the query that the enterprise had in the first place. Now, the reason for setting it all out like this is just so you understand. If you think the answer to your very complicated and knotty enterprise problem is in some frontier model waiting to happen, I've got bad news for you. It isn't. But where it will be solved is if you can break that problem down in the same way you do with a human team, to give a model a clear question, a clear ask. You can give it clear and non-contradictory data. It knows what it can and can't do, and you take it through a process. And if you do all this, and we call this, by the way, precision agents, and these are connected precision agents in a workflow, and to put them in a workflow like this is to orchestrate them. And so you will have heard me talk about agent orchestration. That's all it is. It's not complicated. It's just breaking down big things into smaller things so that the machines can use them. But if you can do all this, you'll get a much better quality response. And because you're asking much less of the machine, not only will they do better, but you can potentially use machines that cost a little less. So for all these reasons, to get the enterprise result you want precision agents orchestrated into a workflow in a way that's convenient and simple and repeatable for your organization to use. I hope this helps.